They couldn't stop their offense. The Packers.
I'm ready for 3 interceptions. I'm ready for that.
No.
Yeah, we had to.
There's a big
Well, like
hole.
3 times. I was like, can we really have a touchdown? That's so bad.
I don't know what the score was
Hey,
doing.
why did they kick a field goal?
That's a real question. Down by 8 with 2 minutes left.
And acting like Tom
Next year.
Brady's not gonna find out a way to run the ball.
It's a scam.
I'm
Football's all
talking
scam.
about.
How's their weekend?
5 days to do a draft. Me?
I have money. I just.
We do.
I still, some of the stuff from like last year is confusing.
Uh-oh.
I have a high tolerance. That's all I'm tired of.
Is that bad?
No, I
Yep.
do too. The thing is, it's
Like-
like, even if I just-
I don't know. It's just hard.
But I'm still like,
If it was easy, they would not call it AP statistics.
So wait,
my dad and I-
I'm confused. Can you work it?
My dad wakes up in the
I can't think of a
See,
problem.
my issue is I don't understand the last unit sometimes, and then that goes over to the
It
next.
really applies this
And
time,
that sucks.
Wait, really?
really.
I feel like the last unit we've done all year.
Last unit
Yeah.
It was just difficult.
will take over the entire semester.
There's
Are
3
you
people on there
serious?
already.
Egg Catherine.
Can I, who's in
Let's go. See, I got comments on there. How about that?
Who's in it?
Commenting.
That was Brock.
I'm gonna throw Drew and Zach to join the live.
Just not read the board since it's backwards.
It's not bad.
It's not backwards to them. It's weird. I thought it was backwards.
Silly goose.
It's not backwards to them for some reason.
You just see it differently?
Yes, it's weird.
Do they have to search up?
So
your
what I told
YouTube?
them, if y'all didn't see, right, I think what the best way, because I can't see these things pop up right during the lesson, is if you guys, so on Thursday or Wednesday, if you guys have a question or some sort, just text your buddy and just have them say it. I mean, I think that's probably the best way, if you're watching it live, and you don't have to watch it live, I don't care, do whatever.
Are you
But we
gonna,
can watch it live from, like, someone in class could have it on live and then like.
Yep.
Say, oh, so it's. a-
Sure.
Should we just FaceTime someone in?
That's fine, if you want to do it that way, I don't
Does
care.
this save?
Yes, so that's why I say you can watch it now, or it'll save and you can watch it later.
Okay.
I feel like
Fair
it's kind of
enough.
unfair. The Chiefs
But I
have to
feel
play
like
Tampa Bay and.
I'm
Tampa.
sorry?
Do I have to like look it up on YouTube?
No, the link it'd be the same link that's on the classroom.
Oh, okay.
You
What
went
else?
down 2 viewers, Coach Bear.
How is it fair we have to
You
play
had
Tampa
4,
Bay?
and
Oh,
I
they already
had
quit? I probably said you don't have to watch it now. They said, okay. What was your question?
Why do we have to play Tampa Bay and Tampa? Seems a
Uh,
little unfair. Just saying.
First time it's ever happened.
Oh, now they're back.
Now they're back.
They heard me.
All right.
Give your donations turned on.
No, Catherine said it keeps on freezing though.
Oh, does it?
Yeah.
That's disappointing.
There's 4 now.
Dang
We're
it.
growing.
I wouldn't think it
Are
should.
you guys going again?
All right, 8.2. Probably, so what I'm covering today will come up again in 8.3. It will come up again in 10.2, 10.3, 12, 13. It's going to come up like 6 or 7 times through this semester. So if you watched my 8.1, and again, I rushed through that one pretty quickly because I knew most of that was going to be covered here, so I'm not too concerned with it, but it will help you a little bit just to hopefully understand some things. There are 2 major topics in statistics that we need to cover rest of this semester, and one of them is confidence intervals. The other one is hypotheses testing, and hypotheses testing will be next chapter. Confidence intervals. There's confidence intervals for proportions, and there's confidence intervals for means. Luckily, the only one we're going to talk about today is for proportions. On Wednesday, it will be for 2 sample proportions. And that lesson will go really, really quickly, which is one reason why I want to make sure that I cover this one in depth. Okay? So if you can understand this one today, then the one Wednesday will go very, very, very quickly, because I think you already understand sampling distributions between 1 sample and 2 samples, or at least for somewhat you do. So estimating proportions with confidence. What this means, right? More times than not, in real life situations, we do not know what the population average is. We do not know what proportion of cars are white. We do not know that. We do not know what proportion of M&Ms are blue. We don't know that. They tell us what they think it is, but we don't know that for a fact. So there are many, 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 many things in life we do not know what the population average is. So what do? Well, we get a sample. We get a sample. Is that sample going to be the same as the population? Probably not, because of sampling variability. If I get another sample, is it going to be the same as the population? Probably not. And not only that, it may not be the same as a sample. So at what point do we need to think that we actually know what the population average is? Well, again, sometimes we just don't know what it is. We just have to guess what it is. And so we will do a confidence interval. We will give an interval of plausible values. And that's what we talked a little bit about in 8.1. They use the word plausible as opposed to possible. I think it's kind of the same thing, but one of the slides explained the difference between plausible and possible, okay? But it's going to give me an interval, and that's where we really think the population lies in there somewhere, okay? And it depends on that interval. We can make that interval narrow, we can make that interval wider. And so depending on what we play with these numbers is how that interval behaves. So we're going to estimate a population proportion in this lesson today. By the end of this lesson, hopefully you can state and check the random 10% and large counts conditions. These conditions are huge, and I will make sure that they are emphasized more. If they're huge, you got to know these conditions. And not only do you have to know them, you have to check them. And we've kind of talked about them. They're the same conditions as we talked about last chapter. Determine the critical value for calculating C confidence intervals. That is probably the most missed thing. So when we cover that, I want to make sure that we emphasize it a whole lot. Construct and interpret a confidence interval, and that actually is not that difficult to do. And then determine the sample size, and that's not that difficult to do either. The doing this is not that difficult of a task. Understanding it and explaining it, sometimes that's a little bit more difficult. All right, here we go. Let's say we take a U.S. sample of households and found that 47% of them own a dog. I took a sample of U.S. households, 47% of that sample owned a dog. Fair enough? Do we think that that's the same as a population? We don't know, right? We don't know. What's going to determine that? Well, it determines maybe how big of a sample I took. It determines maybe even where I got the sample from. All those type of things is going to help determine that 47% compared to the population, okay? If we took another sample, is that going to be 47%? Probably not, because of sampling variability, with things we just already talked about. So how close do we think that 47% is to the population? That's the big thing we want to talk about. How close do we think it is? Well, again, we don't know. We think it's close, but a lot of it's going to determine on how we took the sample, right? If that's just a sample of 10 people, we don't think it's very close. If it's a sample of 18,000, now we're going to think, oh, that's probably a pretty good little estimate. So depending on several things is how close we think that 47% is. All right, let's see what else I got up here. Okay, just make sure I emphasize that, right? Confidence interval are plausible values from an unknown population parameter. More times than not, we don't know what the population average is. Population parameter. So we get a sample. We think that that sample is pretty close to the population, but we know it's not. So we're going to give an interval of possible values or plausible values, okay? We can use what we know about properties about sampling distributions to help us determine these plausible values. Here we go. Here's the formula that you're going to need to know. You're going to use this formula, this chapter, next chapter, the next chapter, and you're going to use it about 5 or 6 times on the AP exam. This formula is in words. This formula is in words. It's going to be your job to turn the words into variables. And so you can see I have 2 different things out there. So one of them in words and one of them in variables. But here's what it is. It says the statistic plus or minus critical value. Statistic plus or minus critical value and that's times, statistic plus or minus critical value times the standard error of the statistic. It looks pretty confusing, but we'll break it down to where it will not be, I hope. Statistic plus or minus critical value times the standard error of the statistic. This links to our formula sheet. And if you go to your formula sheet and you go down to right here, it's written in words, statistic plus or minus critical value, standard error of the statistic. So it's on the formula sheet written in words. It's going to be your job to turn the words into variables. So let's go through each one of these and make sure you understand which or what the word means. Everybody okay? Everybody good? My pencil still going? Happy? Everybody happy? When the standard deviation of a statistic is estimated, we call it a standard error. All last chapter, we called it a standard deviation, right? Standard deviation of the statistic, standard deviation of the sampling distribution. Now, because again, we're estimating all these things, they're going to change it from standard deviation of the statistic to standard error. Just a terminology you kind of need to be aware of. Standard error of the statistic, when the standard deviation of a statistic, remember statistic means sample, okay, is estimated from data, then the result is called a standard error. I don't use that word as much as I should, but y'all try to correct me when I say standard deviation of the statistic or standard deviation. Just try to get me into the standard error. Y'all okay with that definition? I think it comes up again. All right, it doesn't. Y'all okay with that definition? Just standard error. It's just, it'll make more sense when we do this, I think. I hope. Statistic. What do you know about a statistic? It comes from a what? Sample. So if we're talking about proportions, we're talking about what type of variable? P hat. Fair enough? If we're talking about means, we're talking about X bar. So the statistic is that, guys. It comes from the sample. It comes from the sample. I think if you watched 8.1 a little bit, they called it, what do they call it? The estimator or something like that. I'm not, like I said, I'm not too big a deal on it, but it's that 47% of people that own a dog. That's the statistic, right? Again, in this chapter or this, if it's categorical data, proportions, it's going to be P hat. It's going to be P hat. If it's numerical data, then that's going to be X bar. So that's what the statistic is. And so that's what it is as a variable representation. It's going to be X bar or it's going to be P hat. In this chapter, we're only talking about proportions. We're not talking about means. We're only talking about proportions. So that's going to be P hat. All right. That part's pretty easy to understand. I hope it's not too big of a wild goose chase. Critical value. Okay, let's talk about the critical value. Let me get my little button here. This is asterisk, whatever we got to do. This is probably the most missed part of it. And when we get done with it, you're probably going to think, if that's the most missed part, then this is not that bad. Because it's not that bad. It's just the most missed part. It is the Z-score associated with that confidence level. It's the Z-score associated with that confidence level. The level will be given to us in the problem. The level will be given to us in the problem. Or if it's not, we will use 95%. So a couple more slides later, we'll make sure you understand how to find that.
Did I say Z-score like equals confidence level?
Yep. Z-score, well, yeah, technically that's not right, but that is. Mentally, that's right. Fair enough? You're going to get it from the confidence level, but the Z-score is not going to be 0.95. Fair? You're going to get it from that. And I got a couple slides later that's going to show us how to get it. Talk to them.
So I know that the 95% comes from the empirical rule
Yep.
with the 2 standard deviations.
Yep.
Why is it 2 standard deviations?
Because
It's at home.
2 standard deviations. Hello. She's supposed to be down there already, I sent her. Okay.
She's different. What's that for?
So the reason why the Z-score is 95% is because 95% of the values fall within 2 standard deviations.
You see, I understand that part, but why is it 2 standard deviations? Like, why is it not 1 or why is it not 3?
If it's 1, then it's 68%.
And then wouldn't 3 be a better estimator though?
3 would be 99.7.
So then why don't we just do 3?
Okay, we could do 8, right?
That'd be like-
But you're going to get wider and wider and wider because as that confidence level increases, your interval increases. And we don't really want it to be wide. Like I could say I'm 100%. It could be between 0 and 100.
But then you don't have the standard error.
But now I don't have like any idea what the population average is. So the wider I make it, the less I know what the population is.
Why is that?
Well, don't you get a bigger like margin of error?
You get a bigger margin of error.
The like larger your
Yep.
whatever it is.
As we progress on with that. But that's also, that comes with it, right? If I want to narrow that down, then I'll just use 1 standard deviation. If I want to be a little bit more, I'll widen it out and I'll say 2 standard deviations.
So it just depends on how accurate. you
Depends
want
on
it, or, like,
kind of how accurate I want it, how wide I want it to be. How about that?
Okay.
I don't like using the word accurate. But how wide I want it to be, although it's kind of on the same lines.
Okay.
Fair? I mean, I can say for 5 standard deviations, but then I'm just making it wider and I don't know if that really gives me a good estimator of the population. You know, if it's between, it's kind of like the weatherman, right? There's between a 5% and a 90% chance it's going to rain today. I don't have a clue if I need my umbrella or not. He's not helping me out a whole lot, right? I mean, he's pretty accurate, but I told you it could or couldn't.
So you prefer like a tighter?
So we like it a little bit tighter, right? But at what point do we like it so tight that maybe we didn't get it? Fair? Everybody else, y'all okay? Good question. Okay, it's the Z-score. Again, we got a slide that goes on that in just a second. The standard error of the statistic, you already know what this is. We have already done this part of it. We did this part all last chapter. The only difference was last chapter we used P's. The standard error of the statistic is P hat times 1 minus P hat over N. It should look very, very similar to what we did last chapter, right? P times 1 minus P over N.
So what that equals, determines what?
That's the standard error of the statistic. Okay. Last chapter, it didn't have the hats. Now we got the hats. Why do we have P hats?
Because they're fancy.
Proportions.
P's were proportions too.
But you don't know the population.
You don't know the population average. That's why we're doing these, right? We don't know what the population average is. We don't know what the population average is. So if we don't have the population average, how in the heck are we going to use a P? We don't know what it is. So we have to use the P hat because that's the only thing we have to go off of. Is the P hat accurate? I don't know, but that's the only thing I got. It's more accurate than just guessing. Right? If 47% have the dogs, if that was for my sample, I'm going to use 47%. That's better than me just guessing that it's 20%. So that's why that's a P hat now. And again, if you go to our example, I'm sorry, not our example, or our formula sheet now, right? This is where some of you guys may have started seeing that a little bit. Parameters, this is proportions, parameters of sampling distributions. Here's mu and here's sigma, right? And this was all stuff we did last chapter. Standard error. and this one shows P hat. So even though that formula is on your formula sheet, not written with variables, it says standard error statistic, you can go right to the next page and you can see standard error of statistic. And you can see that formula, P hat, 1 minus P hat over N. Good enough there.
Sure.
Okay,
What'd you say standard, like the difference between standard error and that is?
the standard error and the standard deviation of the sampling distribution. Standard error is just the easier way to say it. Standard error comes when we have to use P hat instead of P. I'm not too concerned that y'all know that. You're just gonna see the word standard error, and I don't want that to confuse you. If you see standard error, it's P times 1 minus P over N, but typically it's P hat times 1 minus P hat over N. You see standard deviation is P, 1 minus P over N.
So like on the exam, it'll say like standard error if it's asking for like the P hat.
Yes. Everybody okay so far with the formula? Now we have it in words, and then there it is in variables. P hat plus or minus Z, they put a star there. Don't let that concern you. If you want to put the star there, do. If you don't have to. I never do.
What's the stars?
It just, we'll kind of explain it to you when we start finding it. I'll try. And then the square root of P hat, 1 minus P hat over N. When the conditions are met, a C confidence interval for the unknown proportion is this formula. Now, this formula is not on the formula sheet. This is what you will have to write down on your test. They don't want it in words, they want it in the variables. But I think it's pretty easy to turn it in from the words into the variables. Statistic, critical value is the Z score, and then the standard error, the statistic, and that actually is on your formula sheet.
Why is it plus or minus?
Huh?
Why is it plus or minus?
Because that's the margin of error. That we'll kind of get there in just a second, right? Z star is the critical value for the standard deviation, where percent Z, this is called a one sample Z interval. That's going to be important to know also, because we'll say it in words and then we'll say it with a formula. We'll say it in words and we'll say it in the formula. One sample Z interval.
That formula is the one,
Go ahead. Yes.
so that formula would be the one sample.
Yes, that is the one sample Z interval for proportions. Woo. You okay? One sample Z interval for proportions, because we have P hats. All right. Now, let me slow down and get everything going. So far, the big thing we need this chapter right now is this formula and the one sample Z interval. Okay? That's what you need to understand so far. Go ahead.
Under the formula and variables, is this what you want us to? find?
Yes.
Okay.
Yes, this is the formula in variables. And again, you do not have to put the star. You can't put the star. That's not that big of a deal. I never do. But if you sit there, just understand that it's nothing different. Go ahead.
This ends up being the C percent, that variable.
You get that variable from the C percent. So if it's 95%, that's 2 standard deviations. So if it's 95, that'll be 2. If it was 68, that'll be 1. Fair enough? If it was 99.7, that'll be 3. Fair enough?
The answer to this equation is the average of the population.
The answer to this, when we do P plus this and P minus this, that's going to give us our confidence interval. Fair enough?
Yep.
Does that help you with the plus and minus now?
Yeah.
Everybody else okay? Y'all are asking great questions. That way I kind of know where you're at and where you're not. Z is the critical value for the standard normal curve with percentage of error between the, this is called the one sample Z interval. Okay. Everything should be pretty easy because they're going to tell us what p hat is, or we're going to be able to find it. That p hat and that p hat's the same. That p hat, they're going to tell us the sample size, and they're going to tell us a confidence level, and we have to figure out what the Z score is. So pretty much the only figuring we have to do is that Z score. Okay. Which I think is, oh no, there's conditions. Let's talk about the conditions now. Conditions are very, 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 very important. And the conditions not only must be checked, but you must verify that you checked them. If the conditions are not met, we cannot use this formula. There are 3 conditions that must be met because basically there's 3 parts to this formula. Okay, so here is the first condition that we're going to talk about. We're going to talk about that p hat. In order to that p hat, what must we have? We better have a good random sample. It better be a good sample from the population. Be sure that p hat is a valid point estimate. There's that word that we use in 8.1. We check the random condition. That's what they call it, the random condition. We want to make sure that this is a random condition. It's randomized. The data came from a random sample from the population of interest. If our data is not random, this must not be a good p hat estimator. It's biased. If it's biased, it's not a good p hat.
So would they tell us in words that?
More times than not, they will, Jacob. They will say, we got a random sample of. I have never seen that violated unless they led you to believe that a condition was violated. Does that kind of make sense what I'm saying? They will not ask you to do a confidence interval if one of these conditions is violated. They will ask you, are the conditions met? Something like that, to lead you to believe that maybe they're not. So they will not try to trick you and throw you something in there to say, do a confidence interval and one of these things be violated. A lot of times, this is an assumption. We just have to assume that it was a random sample. There's nothing to believe me that it's not. Y'all okay with that?
Yes, sir.
Say it's got to be a random sample, and not only can you got to check it. And when we do our example here, I'll show you kind of how we check it. Okay, random condition. All right. If it's not randomized, this will not be a good p hat. The next condition that must be met is to get that Z. Well, in order to get a Z, what better our shape be? Normal or approximately normal. And so they're going to call it the large counts condition. That's what this book does. They call it a large counts condition. I kind of like it because it makes more sense on the AP exam. You can call it the normal condition. You can call it the NP rule. I don't care what you call it, but somehow or another, we got to make sure that N times P is greater than 10 and 1 minus P is greater than 10. Because if it's not normal. And if it's not normal, we can't use a Z-score if it's not normal. It's got to be approximately normal. It's got to be approximately normal. Again, notice that they have hats right here, right? Why do they have hats? That's all I got. That's all I got. I only got the hats. I don't have a P. So I got to use the hats. Now, let's see, what else? No, they didn't say it there, so we'll talk about it later. So they're going to call that the large counts condition or the normal condition or whatever you want to call it. In order to use this formula, what had to be special? The sample had to be,
Random.
no, that was the P hat. Less than 10%. Less than 10%. The 10% condition.
I thought we were.
Whenever we are sampling without replacement, that's the key. if it's without replacement, which is more times than not. If it's without replacement, we gotta use the 10% rule, because the 10% rule validates that formula. And our sample must be less than 10% of the population. I told people they could send me a remind text too, and I would actually get that. So that's why there's three conditions, guys, because there are basically three parts to this formula. The P hat, which basically says we must have a random solution or random sample. Z, which says we must check normality. And in order to use this part of it, our sample has to be less than 10% of the population. If it's without replacement. If it's with replacement, we don't care. That will hopefully will make sense to you as we progress on throughout this chapter. Okay, any questions about the conditions? Three conditions are very, very, very important. Not only are they just important for you to look at it, but you must verify that you checked it. So we'll have to verify it in words. I think this is an example. Is this my example? Oh, yeah, here it is. Okay, random, 10%, large counts. The data must come from a random sample from a population of interest. The 10% when sampling without replacement, you must be less than 10%. That's a little confusing because the other one has to be greater than 10. Sample has to be less than 10% of the population to use the 10% rule. It has to be greater than 10 in order to use the large counts to prove normality. Okay, so the only thing I got for you on that, guys, is there's three parts to the formula. Therefore, there's three conditions that have to be met. If the SRS is not met, then you can't use P hat. If it's not normally distributed, then you can't use the Z. If it's not less than 10%, we can't use the square root. We can't use the standard error formula. So that's why we have to check it in order to verify we can use that formula. Here we go. How do we get that Z star score? That's important. That's what you gotta know. Huge. And this is the most missed thing. When students miss a question on the test, 9 times out of 10, it's because of this part right here. Finding the critical value Z for a 95% confidence interval starts by labeling the middle 95%. It's the middle 95%. Now, according to the empirical rule, we learned that the 95% is 2 standard deviations away. We're trying to get a little bit more precise. That 2 is an estimate. It's not exactly 2. It's just an estimate. So we'll talk about that in just a second. Under the standard normal curve and calculating that area of each tail. Now, the reason why they're kind of talking about this, guys, is because calculators used to not have that fancy little button. Now, if we've updated our calculators, and you guys have some up-to-date ones, I really don't need to worry about the tail. All I really need to worry about is that middle 95%. But some of our calculators do not do the middle 95%. So we need to worry about the tail. If it's 95%, we got 5% left over. That must mean that this is 0.025, and that must mean that this is 0.025. Because it's always split in half. Okay with that? Here's a nice little curve. Here's the 0.025. Here's the 0.025. That's 95%. You have to do one of two things. You have to find the Z critical value from the table by using the Z score table or by using our calculator. That's about the only way to do it. Unless if you have them memorized, which you'll have this one memorized before too much longer. If I use the table, I have to search for the body to find the 0.025. Again, just to show you that that's why I don't use the table. I have to go inside of this table and find 0.025. Fair? That's what we gotta do. So if I find 0.025, 0.023, 0.022, 0.024, 25, 251, 248.
Doesn't exist.
Doesn't exist. That's part of an issue too. It's 025. Oh, see, I was messing up. 0.025. Okay, this might be a little bit better. 0.025, 0.025, 0.0256, 0.026, 0.025. Right there. It is right there. Negative 1.96. Anybody got a wild guess of what that other Z-score is over there?
Positive
Positive
1.96. Ever so smart.
You are. Well, remember when I told you that 2 was just an estimate? 2 is just an estimate for that Z critical value. It's not really 2, it's 1.96. It's really close to 2. 1.96 will give us a better estimate. If you use 2, I don't think AP is going to get you. If you use 1.96, it's going to be more accurate. Fair enough with that? Now, again, that's a little hard to do to find it in the table, but you can do that. If we don't do it in the table, we can use our calculator, right? By using second distributions, and we go down to inverse norm. Enter 0.025. And you paste it, and you get that same negative 1.96. And actually, it's even a little bit more accurate than the table. It's actually 1.9599, which is really close to 1.96. Here's where students mess up, right? They say, find Z critical value for a 88% confidence interval. And more times than not, students will go right to here, and they'll do this, and they'll go inverse norm, and they'll go 0.88. That's big bad, right?
Could you do it for the center? Like if you change
So, because I have center, I could do it that way. If you have center, you could do it that way.
Go.
But if you don't have center, then we need to do just a little bit of math here and do 0.88 and however you want to figure out the two tails. You know, there's what, 12 left over, 0.06.
So it's pretty easy to find.
It's not that hard to find. It's just the most missed thing. Y'all start to think, well, if that's the most missed thing, I think I'm okay.
Right, so just have to label the middle thing and then do the inverse norm to find the average.
Correct.
What is it out of? Oh, I think it
Yep, it's okay. You're good.
was
I thought you did the, like, 0.06.
So I will put 0.06. That's why I say that's where students miss this. Fair enough?
Yeah.
0.06. And they will find that to be negative 1.55. 2 decimal places is fine
And that's the thing that you plug into the formula, right?
for the Z critical value. And remember, it's plus or minus, and that's why we have a plus and a minus value. So this one over here will also be that'll be positive 1.55. And what, let's see, 88, 9, 10, 11, 12, 13, 14, 84%, right?
So would the 0.88 be like 3.9 or 0.99? Would it be like 3.92? I'm just confused how you get like the middle.
Oh,
They give it to you.
they're going to give you that value.
Oh, they're gonna give you what 95 is?
The confidence level.
They'll say it's 95, but then you'll have to find the rest.
Yeah.
Yeah, I know. I understand that part. Like, what do you do when you find the two tails?
Well, that's going to go in your Z score formula. That's going to go right into the formula.
Like, I go to class.
Like, secret class.
So the plus or minus in the formula takes care of the left and right.
Yes.
That's so embarrassing.
What am I doing wrong? What was it supposed to be?
The
88,
0.06.
88.
9, 10, 11, 12,
Wrong
13.
email.
Oh, 94. Duh. 94. carry the 1.
Why you do?
0.94.
It's like an interview.
I don't know, I hope not.
There. That's the positive of it. Good enough? Now, again, my calculator is fairly nice. It's up to date. It's a little bit newer. You can actually do the 0.88 and go to the center. Paste it, and it's going to give you both of them. It gives you the negative and the positive.
Well, that's nice.
Okay with that, kind of see? If you can do a little bit of programming, guys and girls, whatever, I don't mean guys as guys, but some of you people are pretty smart with that kind of stuff. You can, I used to have students program that in their calculator. So they would enter the value, would subtract 1 from it, divide that by 2, and find the tail area.
I don't think
That kind of makes sense what I'm saying. But I hope you kind of understand, right? All this stuff is coming at you one time and you're taking this test and I'm going to ask you for the 96% confidence interval, 0.96. Now, you can't do it that way unless you got the middle. Unless you got the middle.
What do you-
Or you can look at it in the table, which
What do you mean you have in the
middle in your calculator.
The updated calculator.
if- do we have to show our work for this?
You absolutely, there is absolutely no work to be shown.
Like, yeah, we don't have to write down our calculator.
You do not. In fact, you don't even have to draw it. It helps. It always helps to draw that, but you don't have to. If you draw it, then you're less likely to make the mistake of doing the wrong inverse. But there is no work to get that value. You just have to make sure you know how to get that value.
But the real work would be showing the formula, right?
Yes. Y'all okay?
So if it's asked for an open response, you just have to show the formula, you don't have to show this.
Show how you got the
Yeah.
Z-score correct.
Okay.
Okay? Using technology, the command in 10 gives you the negative 0.96 and also the positive 1.96, whatever. Determine the critical value for a 90% confidence interval. 90%. This is the second most common interval, 90%. So we know if it's 90%, there's 10% left over, or 5 each tail. Got our calculator, we would do inverse norm of 0.05, or you would do inverse norm of 0.95, either one, or we'll go to this table and we'll find 0.05 inside of here. 0.05, 0.05, 436, 427. Wrong way. 526, 505, 505. Here's 505 and here's 495. So it's not, actually it's exactly halfway between there. Negative 1.64.
It's not the. Why do you ever just not use your calculator?
So I'll have one or two that don't do it every year, but y'all kind of see the issue with that. When you could just type in negative or 0.05 and your calculator is done. Inverse norm, 0.05. Let's go back to left that way because that's what everybody has. And there's a negative 1.645. Using table A, 1.65. Using calculator inverse norm of 0.05, you get negative 1.645. Or you can use inverse norm of 0.95 and get the 1.65. Or if you happen to have the middle, you can do the negatives if they give you both of them. When you report the Z-score, for instance, somebody asks you, like one of the test questions or one of the homework questions might ask you what the Z-score is, typically you just report the positive one. Typically, you just report the positive one. But hopefully you understand that the positive one and the negative one are the same because there are that many standard deviations away from them. All right, you good? You kind of have a squinchy look, I think.
Wait, when do you just use?
When they ask you on the test question or whatever else, typically when they ask you for what is the Z-score, typically you just give them a positive. Okay with that? Anthony, you okay?
Yeah.
Mr. Blake, you good? All right,
For now.
for now, good. So like I said, I'm not lying, that's probably the most missed thing,
Seems fairly,
and it's not that difficult. Now, the next difficult thing is punching all this crap up in your calculator. That's difficult. Y'all can see that, right? You got a number plus a number, square root number. There's a bunch of calculations going on here. 4-step process. Here's the 4-step process, guys. These 4 steps are going to get you through the rest of this semester. These 4 steps are going to get you through the rest of this semester. Now, the 4 steps they use in this book are a little bit different than the 4 steps that I've used previously. So if I go to my 4 steps or their 4 steps, just kind of understand, we all cover the same thing, and it does not have to be in any particular order. But this is the 4 steps that they use. State the parameter of interest. The parameter of interest. The parameter of interest. State the parameter of interest. And the confidence level. The level is the 95% or the 90% or the 88% or whatever it might be. Again, they will give you that in the question. If they don't, we're just going to use 95. State the parameter. State the parameter. Plan. Identify the inference method. Check conditions. Identify the inference method. Check conditions. Again, guys, this is going to get you through the rest of this semester. I'm going to say state, plan, blank, blank, right? I'm going to tell you the 4 steps. Identify the inference method, check the conditions. How we doing on time? Pretty good. Identify the inference method. In this section, it's going to be a 1 sample proportion Z interval. 1 sample proportion Z interval.
For this unit test, it's gonna be that, or for just for?
Next section is going to be 2 samples. Fair enough? But they're all going to be proportions. They're all going to be. Now, when we'll start adding to it, right? By the time we get done with this, it'll be like 8 different methods.
it's so unnecessary.
Yeah, so depending on what the type of problem is what method we're going to be using. Very few times do students miss this part on the test. The only time you miss it is you forget to state it. There. It's not that you're doing the things wrong, you just forget to put it down. So state the method, check 1 sample proportion Z interval. Fair enough?
No.
Shut up.
And so,
Where's my stick?
so for these 2, it's just the 1 and 2 samples?
Yes, ma'am.
And that's the inference method?
Yes, ma'am. For this chapter. The 2 sample won't come until 8.3. Do, this is one, just do the calculations. Here's what I will tell you to do is write the formula. Write the formula in variables, write the formula in values. Just write it twice. Write it in variables, write it in values. And then find the interval. You do not have to show your work for the interval. You know, you don't have to show step by step on how to get that value. They just want the interval. If the conditions are met, perform the calculations. They're going to be met. I'm going to tell you right now, they're going to be met. If they're not met, they're going to have you do something else to tell you. Typically what they'll do is, are the conditions have met? And if they're not, then you have to state that right through there. Then it says something like, typically on the next question, it says, assume that they have been met, perform a confidence interval. They do if they are not met, which is kind of stupid. A lot of times what they'll say is advanced statistics have shown that this distribution is okay to use a z-score or something like that. I don't know. And then the last thing is conclude. Conclude. Interpret your interval in the context of the problem. At some point, you're going to get tired of hearing me say the context of the problem, right? Interpret it in the problem. Once you understand how to find that z-score, once you understand how to get that p-hat, and once you understand how to the standard error, these problems are not that difficult. They take a while because you have to do all these steps to do it, but it's not that difficult. Parameter of interest, appropriate inference method, and check the calculations, do the calculations, check the condition, do the calculations, and then conclude it. Your whole life, you've heard E equals MC squared. I do MC cubed.
Isn't that like a science thing?
But you're just special like that.
So this is the steps I do instead of, was it plan, do, calculate, conclude? I do MC cubed. Method.
Oh my god. That was an actual math.
Get my stick. Fine. Get my stick. I'm very glad YouTube's running.
That's a really great way.
I would hit pause and tell every student to turn around real quick and then deny everything.
It's humidity to plant.
Method, conditions, calculations, and communicate your results. However you want to do it. So this is what I'll say a lot of times. Method, one sample proportion Z interval. Conditions, you check the conditions. There's 3 conditions. The 3 conditions must be met. We'll calculate, we'll write the formula, we'll write the word, or we'll write the letters, the values, and then we'll get the interval, and then we'll communicate the results. It will always be in context. It could be MC to the 4th, communicate in context.
Right.
All right. Again, the book's going to talk about what? Think, plan, state, plan, do, conclude. That's what your book's going to do. So they're going to go through those. My MC cube kind of skips the state part. It's in it. That state comes into my conclusion because I concluded concluding what I want to do or what I found. Here's a question. Let's see if we can do the whole thing. A recent poll of 738 randomly selected cell phone users found that 170 of the respondents admitted to walking into something or someone while talking on their cell phone. Construct and interpret a 95% confidence for the proportion. Look, they put the word proportion there. So it's not going to be confusing if this is proportion or means. They're going to put it in there. Of cell phone users who would admit to walking into something or someone while talking on their phone. Very, 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 very similar question to what will be on the AP test. They'll put that up there and they'll give you a whole page. Okay? And it's going to be worth 4 points, 3 points, 2 points, 1 point, 0 points. In order to get all 4 points, we got to do all 4 things. You better talk about the method, you better explain your communication, you better check the conditions, and you better have a conclusion in context. Talk to me.
Isn't 170 more than 10%
Of what?
the population?
What's the top, how many people use cell phones?
Yeah, it's a 780.
Okay, so that's my sample,
Yeah,
right? So 730 is my sample.
yeah, I mean, sure.
No, you're good. You gotta see all that stuff. So that's my sample. We have to believe that there's over 7,000 cell phone users. Again, I think at one time I mentioned that 10% is more of an assumption than it. So I'm going to first talk about the method. We're going to do a 1 sample proportion Z interval. We need the word interval because we're doing a confidence interval. It tells you we're going to do an interval. It actually says proportion, so we're going to do proportion. 1 sample because we only have samples. It's only 1 sample. It's the 1 sample of the cell phone users. And the Z always goes with proportions. So that's the method. That's going to be worth a point right there. Now I'm going to let you in on a little secret. AP will say student states what they're going to do by method or formula. I'm going to make you put down both. Because hopefully on the AP exam, you will at least put down one of them. Does that make sense? And I will start lighting up towards the end. So the method right there, that's gonna be worth a point. Oh, mushy mushy. Ah, you're back.
I knew exactly what you were gonna say.
What was mushy?
It always says that.
It's hello in Japanese. So there's my method. Okay, what's the next thing? Yeah, MCQ. So I probably need to check the conditions. So let's check the conditions. What's the first condition? Random sample. We have 738 randomly selected cell phone users. Says so right there. Conditions, random selection of random, and then put a little check mark or whatever you want to do. Don't care. And show that you checked it. You got to state it and show that you checked it. You don't really have to put the check mark out there, if that makes sense to you. But that's pretty easy. I mean, how are we gonna know? Well, heck, it's written right there, first sentence. First sentence. What else do we need to know? Carson already admitted to it, right? The 10%. Because these are sampled without replacement, we need to check the 10% rule. It is reasonable to assume that 738 is less than 10% of all cell phone users. I would not expect you to write all that out. I think I would just write out 738 is less than 10% of all cell phone users. Or I might even go a little bit further and say that we can assume there's at least 7,380 cell phone users. You don't have to state it exactly like they do. You don't have to state it exactly like me. If I grade your test and everybody gets it exactly the same, I'm going to question myself. Fair? If there's 2 people that have the exact same, I'm going to think, right? Ironic. Although it would be very close because there's only a couple ways to say it. So somehow or another, we got to get that 10% in there. Okay? You got to get it in. And like I said, this is probably a little bit too much. We'll assume 738 is less than 10%. I think you're okay to say 738 is less than 10% of all cell phone users.
That's what I said.
I mean, I think you're good with that. Yes, ma'am.
So we wouldn't have to like calculate or anything, we can just say.
That one we just say it, right. And again, a lot of times that's an assumption. It's not necessarily a condition as much as it is an assumption. I don't think there's ever a doubt that it's going to be less than 10%. It's hard to be more than 10%, truth be told. It better be a small population. If it's a small population, we're not going to do inferences. We're just going to get it. What's the other one we need to check? Normality, right? Normality. And how do we check it? We got to do n times p and n times 1 minus p. And n was 738. 738 times p. Actually, they went ahead and if you do n times p, you're going to get 170. If you do n times p, because I shouldn't say p, I should be saying p hat. Bear with me, I'm sorry on that. So p hat equals 170 out of 738. Fair enough, that's what p hat is equal to. Well, if I multiply p hat times p, I'm going to get 170. And if I do 1 minus p hat times n, let's see, 600, 562, 68. I'm not very good with math. I don't care how you do it again. You just got to do n times p and n times 1 minus p, and we got to make sure that that's bigger than 10. And because it is, they didn't even say something about being approximately normally distributed. We should probably say that. So approximately normally distributed. And really this goes back to the sampling distribution being approximately normally distributed. Because that's really what we're doing, is we're doing a sampling distribution. Everybody okay? So, we've stated the method, we've checked the conditions, now we got to do the calculations. Write the formula in variables, write the formula with values. There it is, 0.23, there's p hat. I just wrote it out because I couldn't do it. 0.23 plus or minus 1.96 square root 0.23 times 0.67 divided by 738. I didn't use the formula, sorry. I need to add one there. P hat plus or minus z square root p hat 1 minus p hat over n. And then you got to go to your calculator and figure out those two stinking values somehow, some way, some form, some fashion.
And that's the interval?
Yes, ma'am. Because you're going to do 0.23 plus the margin of error and 0.23 minus the margin of error. And then that's going to be my interval. Any question on that? There's a lot of pencils going, but let me show you something that's somewhat nice on your calculator. Just a little trick that I do. Where am I at? Calculator. Clear. 0.23 plus 1.96 times square root 0.23 times 0.77 67 divided by 738. 738. Enter. That's the high end, right? If I just hit the second key and the enter key, it brings up the whole thing, and I'm just going to go back here and turn that one to a minus. And there's the low end. A little bit easier to do it that way. Maybe not, I don't know. Maybe some of you just figure out the other part of it and just add and subtract, I don't know.
Question.
Talk to me.
This might not apply, but like in math, the square root is plus or minus c.
Yes, so that's kind of part of it, except it does not apply here because the plus or minus comes from this part over here.
Okay.
Point, what, 258? 2 decimal places, 3 decimal places, 4 decimal places, doesn't matter. I typically do 3 on these. 2026 is what they did. 20 to 26. Present. Come on. Oops. Everybody okay?
Sure.
Believe it or not, you can sometimes miss that and AP will still give you full credit. That's why I want you to have, that's why I'd like for you to write your formula. If you write the formula and put the right values in there, typically they'll give you full credit even if you miss the interval, because that has to do with you just not working a calculator right. Has nothing to do with your knowledge of statistics. Now we're going to conclude it. Here's our conclusion. Get it in your head, memorize it. I don't care what you say it really, really close to this. We are. I'm okay with you say I am. I don't care. 95% confident. I am. We are 95% confident that the true proportion, population proportion, whatever, do not use the word sample. Do not use the word sample because that's not what we're doing. We're 100% that the sample is in there. 100% that the sample's in there. We are 95% confident that the true proportion of context, all cell phone users who would admit to walking into something or someone while talking on their cell phone is in the interval 0.20 to 0.26. Memorize it. Write it down so many times that you're going to have it memorized. Do you have to state it exactly like that? No. But you got to get the 95% in there. You got to talk about the population proportion. You have to use a proportion. You have to put it in context. And then you have to tell me the two values. If you want to say between 2 or 0.20 and 0.26, there's 95% confident that the true proportion of all cell phones will be between those two values. I don't care. You got to get it all in there. Again, the difficulty I don't think is very high, but writing everything down and remembering, that's where the difficulty comes into play. That's where the difficulty comes into play. We are 95% confident that the true proportion of all cell phone users who admit into walking into something while talking on the phone is somewhere between 0.20 and 0.26.
The thing is that
So you said, you're saying between 20 and 26%.
And you can say that's percent if you want to, it doesn't matter. Yep. Question. So where most students miss is by putting the wrong Z-score down. That's probably one of the most missed things. The second most missed thing is understanding. Listen, this 95% confidence interval does not mean there is a 95% chance. It does not mean that. We're just 95% confident. It does not mean there's a 95% chance that the population is in there. It's either in there or it's not in there. It's either a 100% chance or a 0% chance. It's not a 95% chance that it's in there. That is probably the most misunderstood thing about these confidence intervals. One of my students one year referred it back to college applications and college acceptance. If a college has a 90% acceptance rate, does that mean there's a 90% chance that you're getting in? No, you're either getting in or you're not getting in. If there's 100 people, 90% of those people are getting in. So what does the interval mean? If I did this over and over and over and over again, 95% of the intervals will contain the true population proportion. But it doesn't mean there's a 95% chance that it's in that one. And that is one of the most hardest things to understand about this. In a free response question, it asks you to interpret a confidence interval. You're expected to do the entire 4-step process. You're expected to do the entire thing. If you see the words construct and interpret, that means you're going to do the entire thing. And there will be one question on the AP exam out of the 6 that will have you construct and interpret a confidence interval. Now, I don't know if it's one sample. I don't know if it's 2 sample. I don't know if it's proportions. I don't know if it's means, but guaranteed there will be one on your AP exam. I don't think it's that difficult. Just trying to remember every single thing. Sometimes it is. Remember that the margin of error as a confidence interval only accounts for sampling variability. We didn't talk a whole lot about the margin of error yet. 8.1 did. If you haven't watched it, you probably ought to watch it. 8.1 talks about the margin of error. Margin of error is everything after the plus or minus. Okay, that's where I say this again. Go away. Exit. Here's the population average, 65%. That is the population average. I don't know what it is. 65% of all the cars are white. I don't know. 65% is the population average. That's the population. I'm going to do a 95% confidence level with a sample size of 50. Uh-oh, what happened? There it goes. Look at there. 0.64 plus or minus 0.13. That confidence interval actually captured the true proportion. Let's do it again. There's another one. That one got it. That one got it. That one got it. 95% of these will get it. All these are getting it. There's one that didn't. That one didn't get it. Is that possible? Yeah, it's possible. That sample proportion was too high. And I went 1 standard deviation and 2 standard deviations away. It didn't get the population. Do we know if we get the population or not? No, that's why we're doing these things. I don't know what the population average is. If I know what the population average is, I don't have to do a confidence interval. Why are we doing one if I know what it is? Okay with all that kind of stuff? What happens if I increase my sample size? What's going to happen to those intervals? I'm going to shrink them down because I become more, my margin of error is less because I've increased my sample size. What happens to my confidence level if I increase that? I think, there it goes. So what happened when I increased that? It made them wider. Because if I'm going to be 99% confident, I want that interval to be a little bit wider because now it's got to capture it 99 times as opposed to 95 times. Kind of see all that? I think if I change this, it makes me redo it. It does. I don't know if you can see the difference between those. Those are a lot smaller, right? There's 1,000. That's a lot smaller interval. Because my denominator, that n value is bigger. When your denominator is bigger, that makes that number small. Probably, I'm going to miss more of these, right? I'm probably going to miss more of these because it's smaller. Actually, I shouldn't miss more of these because it should be the same 95%.
You made it 99%.
Oh, I made it 99%. I'm 97%, 0.9, so I'm a little lower. There's 98. There's 98. I'm still missing it more than I'm supposed to. All right, one last thing we need to cut. This is what I do every year too to help you, I think. It's like college acceptance, that's what I just talked about, right? All right, I'm gonna give you plus or minus 1 year. 1 year. How confident are you that you can guess how old I am? Some of you may know, so it's cheating. That kind of makes sense what my question is. So think about that number. Okay? So I don't know what that confidence level is. Now I'm going to give you plus or minus 5 years. More confident? Because I increase the interval. As the interval increases, your confidence level increases. If I gave you plus or minus 10 years, you ought to be really confident now. So as the interval increases, your confidence level increases. I used to play this whole game and make everybody guess.
I have a guess.
You have a guess?
I'm not telling you.
You're not going to tell me because you think it's going to hurt my feelings.
No, I don't, but what if it does?
Mr. Mayor.
Yeah, that could affect my test score, you never
Sits
know.
up there and makes fun of us all day.
What's your guess, Carson?
On which one?
How old he is.
Well, they ought to be all the same answer.
Yeah.
Can I do plus or minus 5 years?
How confident are
Pretty confident.
you? Okay. You want to guess 50?
Yeah.
What if I gave you 1 year? Would you still
1
guess
year, I
50?
would do 52.
Dude, that you're way older than I think.
49.
I feel like you're.
I feel like
You're
you're
46.
I'm like going off of my
He has
dad's
a daughter
age,
in
so I
high
don't know.
He's,
Yeah.
he's two
Not his
years,
daughter in high
he's 2
school.
years
That's
younger,
where
2
I'm
years
going off
younger
my
than
dad's
Mr. Wells. I know that.
Do
Mr.
you know
Wells.
how old Mr. Wilson
I
is?
think Mr. Wells is in his
Carson's
50s.
pretty.
Mr. Willis is in his 50s.
He told me he was 2 years younger than Mr.
I
Wells.
would say late 40s.
That's what I was.
Yeah, I'm like 48.
You look a lot younger than I think you are, but
That's
I
true.
think
He
you're.
does.
I do not dye my hair, but a lot of people think I do. When I first started teaching, everybody guessed it a whole lot worse.
Like older or
Yeah,
younger?
they guessed a whole lot older than I
Oh,
was.
Really?
They
Oh,
want to
yeah.
see your whole face.
Yeah,
Oh,
that's.
And that
true.
changes it.
That's-
That changes it. I agree with that too. Yeah, they used to guess a whole lot
You don't dye
older.
your hair?
But I think it was because I was a teacher
Oh, and they were.
and they were, you know, a little
yeah.
bit younger. Now it's the ratio type things, you know?
I think you're 48.
I was gonna guess
Yeah.
52, but you like seem younger than 52. But
I act a whole lot younger. than 50.
yeah.
That's why I said plus
He's
or minus
old
5
like my
years.
dad, my dad's.
I know you're early 50s, late 40s, so that's why I guess 50 or 5 plus or minus 5.
What do you tell us?
I am 50.
Yeah.
Oh, you are?
Oh, so I would have missed the whole plus or minus.
What did I say?
My mom.
You hit it?
I said
No, she said
49.
49. She's wrong.
I am 50.
That being old.
Okay,
What did they used to guess how old you were?
but typically it's 45, 44, 45, and I was, 40 at the time.
Oh.
39.
So you just had a big birthday?
In August I did.
Yeah.
Yeah. Do you do anything to your hair?
Still stuck
I
on
comb
my
it.
hair. What if one day you just walk into school with Arctic One?
I got some, it's the gel I use apparently hides it really well. I'm getting them real bad on
My whiskers.
whiskers. I haven't shaved it since this whole pandemic. I just use clippers. I haven't shaved it forever. Okay, choosing a sample size. Y'all didn't care about all that stuff. Fast forward, I hope. Okay, sometimes again, we want to make sure that our margin of error is set at a specific value, just like we did in last section, right? We had to find the value of n. Sometimes we want that margin of error to be set at a certain interval. I don't want it to be a whole lot wider than it is. So in planning a study, we may want to choose a sample size that allows us to estimate a population proportion within the given margin of error. The formula for the margin of error is everything after the plus minus. Okay, it's everything after the plus or minus. It's the z-score, and it's the p, 1 minus p over the n. Again, guys, they have hats on their p's. Why do they have hats on their p's? Because we don't have a p,
Crazy.
right? We have a p, then I wouldn't need to do any of this stuff. So it's everything after the plus or minus. It's just like last chapter, except last chapter we didn't have the z-score in there. Right? We just wanted a certain standard deviation or standard error. Now we want certain margin of error. That's a little bit different. That includes the standard deviations. To calculate the sample size, we'll substitute in the values for z, we'll substitute in the p's, and we'll solve it for n. They'll give us what the margin of error is. We don't want a margin of error more than 0.02 at a 95% confidence interval.
Wait, we don't want a margin error, what? Margin of what? What did you just say?
Here's an example.
They will give, we're gonna do one. They'll give us the margin of error. They're gonna give us the level. The only problem is, what are we trying to find? Sample size, right? That means we haven't done a sample. So if we haven't done a sample, do we even know what p hat is?
Trick question.
Fair enough? See the issue with that?
Dude, just take this random.
If I knew what that is, I wouldn't have to do the interval. That's not what you're saying there. We don't know the value of p hat until the study has been conducted. This means we have to guess what p hat is. What you're going to do is guess something that they think it might be, which very, very seldom happens, because if they think it might be that, I guess we'll use that. But if they think it might be that, I don't know why we're doing all this stuff, but okay. Or we're going to use 0.5. Because 0.5 times 0.5 gives us the worst case scenario. 0.5 times 0.5 is going to give us the worst case scenario, because if I do 0.5 times 0.5, that's 0.25. If it's 0.6 and 0.4, that's 0.24. 0.7, 0.3, that's 0.21. It's getting smaller. 0.5, 0.5 is the worst case scenario. That's the widest it can possibly be. So we will use 0.5 and 0.5 to use our worst case scenario to give us the smallest number possible to make sure that we're going to get there.
Will we ever actually have to use that?
Yes.
So
We'll have an example in just a second.
So when they just don't give us p hat?
Yep.
And they're just being like that?
Yep. Here's an example. Let's hit it real quick. A company has received complaints about its customer service. The managers intend to hire a consultant to carry out a survey of customers. Before conducting the consultant, the company president wants some idea of the sample size that she will be required to pay for. There's a question. We're looking for a sample size. One value of interest is the population P of customers who are satisfied with the company's customer service. She decides that she wants to estimate to be within 3 percentage points. There's my margin of error. I want it to be within 3 percentage points at a 95% confidence level. So I have everything I need except for a p hat, and so I'm going to use 0.5 because that's the worst case scenario. 1.96 is for the 95% confidence interval. There's 0.5. I don't really need to do 1 minus 0.5 because that's 0.5. N is what I'm looking for, and they say less than or equal to 0.03. They don't really use equal to 0.03. They don't care if it's 0.29 or 0.28. They just don't want it to be 0.31, 0.031. And now we got to use what algebra skills we have to solve that for n. So divide both sides by 1.96. Square both sides so you get rid of the radical. And then I do the little flippy flip. I don't know what they did there. Oh, they did the flippy flip. The n goes to this side and all this crap goes to this side. The n goes to that side and all that stuff goes to the bottom. Again, this is pretty quick, little easy algebra, not too bad, I hope. We get 1067.1. And we learned last chapter, we always have to round that person up. So I need 1068.
What equation is that called?
Margin of error. Mo.
So we have margin of error, what's the one that looks like that with?
I'm sorry?
What's the one with the like interval?
That's the confidence interval.
Is that the name of the equation?
The confidence interval equation, I guess. The p hat plus or minus? Yeah, I guess.
Plus or minus all that?
Yes.
Yeah.
Yep. Show you one more thing.
Oh, also, 8.2 is on the back one.
Oh, I gotta do that. Thank you. Yes. All right, one more thing that will help you out. This is do the math. Your calculator's gonna do all the math for you. Just to help you out. Hit statistics and you go over to tests. Go over to tests. Here's a z-test, t-test, test, z interval, t interval, 2-cent z interval. Keep going down. Oh, what does that one say? 1 prop z interval, which if you use your calculator, this helps you to remind you that I need to write that down because that's my method. Fair enough? If I hit enter, X tells me 170 out of the 738. And I want a 95% confidence interval. And if I hit calculate, it will give you those two values. So you don't really have to use your calculator to do all that adding and subtracting.
We got a different answer.
A little bit off.
As long as we
Wait.
show the formula, like we write down the variables and we write down the numbers, we can just push this in and we don't have to.
Oh, how do you use that again?
Stat tests.
That,
And that's the confidence interval.
and all the way
And you
down?
go, you'll start going, actually you can go up. And you'll see 1 prop z interval.
Okay. So, I'm guessing 2 is when you have 2 samples.
There you go. I'll post 8.2 sapling. I'm going on Thursday, I'm going to do 8.3. If you have any questions over 8.2, email me and I will talk about it over this on Thursday. I will run it live on Thursday also. You don't have to watch it live, that's completely up to you. Only people I do attendance for are the people that are supposed to be here.
We're going over 8.3.
So, and I'm gonna teach 8.3. But it will not take probably 15, 20 minutes.
Is that what the favorite test is?
I don't know if I'm gonna use it for this or I'm gonna combine it. I may combine it for next chapter too. Oh, yeah. Talk to me.
So are you gonna put like the YouTube link or whatever on?
It's already there. I hope. Oh, that won't. So I think as soon as I hit end stream. Bye. Was he my